right, interval scale. Interval scale can do everything an ordinal scale can do. Categories are different. Categories are different. Can rank the categories in order. Can rank the categories in order. But now we have that the intervals between the categories on the measurement scale are the same as the intervals between the categories in the true score. So that's what they mean, intervals between categories are constant. What they're saying is that the intervals on your measurement scale are the same as the intervals on your true score. So interval scales are oftentimes confused with ordinal scales. And if you get those two confused, specifically if you're looking at say a psychological tool like Beck Suppression Inventory, and you're asking yourself, is this an ordinal scale or is this an interval scale? Some of them are confusing, and just be aware that it's beyond the scope of this course. There are people with PhDs who dedicate their life to psychometrics, who are trying to determine what scales that we use are interval scales, what scales do we use that are ordinal scales. So just make sure that you get a firm grasp of the concepts behind it. But there is one very clear interval scale that is well known, and that is the scales that we use for measuring temperatures. So temperature, there is a true temperature out there. So temperature is an actual physical thing where it's literally the speed of the molecules and how much they're vibrating and moving. The more they're vibrating, the higher the heat. The less they're vibrating, the lower the heat. So there's an actual physical amount of temperature out there. And here we have a winter's day, here we have an autumn day, and then here we have a warm spring day. You can measure temperature, and there's two widely used interval scales that measure temperature. So here we got Fahrenheit, and here we have Celsius, and you can measure that winter day, and you can measure that autumn day, and you can measure that spring day. And notice that that winter day, which is about minus 10 degrees Fahrenheit, that is here in the true score, and it's here on the measurement scale. And this is the first time that when we measure a second temperature, this autumn day that is 50 degrees, this is the first time that the distance between the true scores is reflected in the distance on the measurement scale. This distance here is the same as this distance here. So this big difference between the winter's day and the autumn day is represented by a correspondingly big difference on the measurement scales. And this smaller difference between the fall day and the warm spring day, the true difference, is represented by a smaller difference between those two on the measurement scale. So that leads to this one-to-one parallel structure, and that's what makes an interval scale an interval scale. It's when there's a small interval in the true scores, there's a small interval on the measured scale. When there's a large interval between the true scores, there's a large interval between the measured scales. That's what makes an interval scale. So on an interval scale, we have those three features. Examples of interval scales. The only real clear example is Fahrenheit and Celsius. I think in all of science, that's the only one where everybody's like, that for sure is an interval scale. And that's why I got question marks here. So personality measures, they seem like interval scales. It seems like we have that talk coming up. Is everyone a psychopath? Right? I think it's today at 5:30, if you want to head on out there. But if there's a measure for people for psychopathy, you can give them a scale. Somebody who scores very low, we assume that they're low in psychopathy. Somebody that scores very high, we assume that they're high. That's an ordinal difference. Somebody that scores slightly higher on the scale, we assume that they're slightly higher in psychopathy. If the intervals on the psychopathy scale match up with the corresponding intervals in terms of the true amounts of psychopathy, then that personality measure would be on an interval scale. And like I said, there are people with PhDs who dedicate their careers to trying to figure this out, that argue about whether personality measures are interval or ordinal scales. So again, focus on what the scales entail, and then in your career, if you're wondering, is a personality measure an interval or ordinal scale, just know that you're not the only one wondering that. Intelligence test, IQ scores. You will hear people taking the average of IQ scores all the time. You'll hear things like the Flynn effect, which is that the IQ scores of today's students is actually higher than it was decades earlier. So if you take the same IQ test from the 80s and give it to people now, they will score higher than the people that did it in the 80s. And they will say things like the average score today is higher than the average score in the 1980s, indicating that they believe an intelligence test is on an interval scale. Whether or not it is, again, that's up for debate. So what math can you do with these scores? Well, the answer for this is you can order the scores. So once again, everything we could do with the previous scales, we can do with the new scales. So you can say 30 degrees Fahrenheit is colder than 50 degrees Fahrenheit. We can put those in order. 50 degrees Fahrenheit is then colder than 80 degrees Fahrenheit. You can put them in order like we did with the ordinal scale, but now we are also able to take averages. And you can intelligently and correctly say that the average temperature this summer was 5 degrees warmer than the average temperature last summer. You can say things like, oh, this is the warmest October on record. Sorry, that'll probably be September. This was the warmest September on record. It beat the previous average by 1 degree. So the average temperature of this September was 85 degrees, it felt like. The highest average before was 84.5, right? You can say those things and you'd be right. You'd get to the true score of it. You would be correct. So again, if you take an average of, I'll make the math easy on me. If you take an average of 10 degrees Celsius and 30 degrees Celsius, right? 10 plus 30 is 40 divided by 2. That's an average of 20. 20 degrees Celsius should be right between the true temperatures of these two days. And if you take a look at 20 degrees Celsius, sure enough, right between the actual true score. So averages on an interval scale measure the true averages in the true scores. Yep.